Hello friends, this is Durga again from ITversity. At this time, we are talking about CCA, Spark and Hadoop developers second module, transform, stage and store. So far we have covered the first two learning objectives, which is to load data from and to HDFS and joining the disparate datasets using Pyspark. And in this video, I will be covering calculating aggregate statistics such as average or sum using Spark. So if you see, the emphasis is on calculate aggregate statistics, and they have quoted average of sum as an as examples, but they can ask any question like min or max or any kind of aggregation as part of the um, certification. So you have to be familiar with others also, not just average or sum, which are emphasized as examples here. Before getting into the hands-on, let's understand the different functions which we have. So to get the aggregations, there are two types of aggregations. One is the total aggregation, the totals. When we say totals, if you want to get number of records in a table, it's total. When you want to get average of all the, so if for a given data set of orders, if you want to get how many number of orders in the table, it's a total. Similarly, if you get into order items and if you want to get the total revenue for all the orders, it's a total. So total means it will give only one value. Um, uh, it will process the entire data set as input and it will give the one value. So to get the totals in Spark, whether you use Pyspark or Spark shell, which is Scala, you have a function called reduce and a function called aggregate. It is not there in the documentation, but I think aggregate also will work without any issues even in 1.2.1. So the purpose of reduce is to use the combiner and get the count or to get the total. Internally it uses the combiner. When it comes to another type of aggregations, you want to get the aggregations by a key. The example is if you want to get the number of orders by status, how many are completed, how many are cancelled, how many are in pending. It is called as the aggregation by key. So you are trying to get number of orders by key order state. In that case, Spark supports that using three functions. One is group by key, and second one is reduce by key, and third one is aggregate by key. So you need to read all the three and the semantics of all the three to understand the differences. So group by key and reduce by key as well as aggregate by key, when you try to get the aggregations by key, will give the same results in most of the cases, but depending upon what you are trying to accomplish, you have to choose them. For example, if you are trying to do aggregations such as sum or min or max, etc., wherein the results are additive. In that case, you have to use reduce by key because it uses combiner internally. But for some reason you think that combiner is not applicable for your aggregation. For example, if you have 1 million records as part of your data set, and if you are if the output will be if the output after the aggregation, the number of records in the output after the aggregation is like 500,000 or 600,000 records, that means the number of records per key are very few. In that case, having combiner can become overhead and it can impact the performance. In that scenario, probably group by key works better. But if the input is 1 million records and output is, let's say, 100,000 records, which is only 10% of the total input. In that case, using the reduce by key, which uses combiner internally, can be far more effective because it will reduce the network traffic for the final task. To understand this, you can go back to my video where I have explained the word count. There I have explained on a whiteboard how the reduce by key works. It actually computes the intermediate results along with the while working with the mapper, and then those intermediate results will be passed to the final task, wherein the results will be added and it will give the results. So aggregate by key also work same as reduce by key, but if you want to provide a custom logic for your combiner, if your logic as part of the combiner is a little bit different from the final logic to get the final results, then you can use aggregate by key. Otherwise, if you don't want to have the custom combiner, you can use reduce by key. So you can read this and make sure you understand these statements, very important, and you should be able to determine when to use what. Group by key when the aggregation is not much, then you can use group by key. When the aggregation is happening at very higher rate, then you should use reduce by key. It uses combiner internally, and if you want to provide a custom logic for your combiner than the reduce logic, then you have to use the aggregate by key. And also it's very important to understand the syntax here before starting developing the programs. Anyway, you will understand that by the end of the videos on aggregations. It will take 3 or 4 videos to completely cover it. So as part of this first video, I will try to cover the total aggregations, such as number of records in a table, or sum of a particular field in a table, etc. Okay, so let's go back here to the script, which is already available in GitHub. Okay, wait. So you can read the data like this, as we are reading. Orders RDD equal to sc.text file, user Cloudera, scoop import /orders, and hit enter. And to get the total aggregation, like count, you can just use count function also, and it will give you the count of the records, which is 68,883. And now if you want to get the revenue, if you look at our order items table, it has the order item subtotal in the table. So if we add, it will give you the total revenue. And the way you have to do it is, first you have to use map function to fetch that order item subtotal. For that, you need to understand which field is the order item subtotal, or which using which how we can fetch the order item subtotal from the array. For that, first we have to see the table details, hit enter, and order item subtotal is 5th item in each of the record if we actually delimit the data by using comma in the map function. So I am reading order items RDD equal to sc.text file, user Cloudera, and hit enter. You can see we have created the RDD for the data, and now you can say order items map, because we have to fetch the fifth item. For that, we have to use map function on RDD, order items RDD, which is created by reading the data. Map function, we can use lambda function here. Let's say it's rec. We have to first split by comma, and the fifth item in array is represented by 4 because the array starts with 0. And now you can actually hit enter, and you can validate whether it is as expected or not, or whether it is fetching the order revenue or not by applying take function on the RDD, and then print the results and hit enter. You see that it is actually fetching the revenue. Now we have to add this. By default, I think it is implicitly casting the data to float. If not, you will see U before it. So we can actually directly add this using the reduce function. So order items map. Now we can use reduce function. So reduce again is to get the total value. Hence, it will not return the collection. So you don't need to do for I in as we are not navigating through collection. You can just type it and it will get you the results. So lambda revenue 1 comma revenue 2, and here you can say the functionality, which is the addition of these two results, and hit enter. Now it is running to get the total revenue. I'm not sure why it is struck. Probably it might be doing some garbage collection. So the reason why it was slow is, you see, even though it does not show with you, it actually treated it as string. So as part of your map function, that's why instead of getting the total revenue, we have got a very long string with all the revenues in them. So to fix this, what you have to do is you have to go back to your order items map function and typecast or convert the data type to float by applying the float function on that. And now if you actually apply the reduce function, it will give you the total revenue, which is 34,322,619 for 1 year data set. So this is how you can actually get the count. And in this video I will also cover how to get the maximum or minimum of the revenue, or yeah, it's not a very valid scenario, but we will see, because I want to make sure that you understand it's not only sum or average, but also you might have to do other aggregations like minimum or maximum. And let's see how we can get let's say the maximum priced product. So for that we have the products table. So let's do products RDD equal to sc.text file /user/ Cloudera scoop import /products, and hit enter. And now we want to get the maximum priced products. Again, we need to validate which column have the the price of the product. Describe products and hit enter. So this is 0th item in the array after delimiting using comma. This is first, second, third, fourth. So we have to, depending upon fifth item, which is represented by 4 in array, we have to get the maximum priced product. So let's do the map first. So products map equal to products rdd dot split, sorry, dot map lambda rec. I just want to return the entire record. You will see how we can get all the details. It's not just the highest price, we have to get the details as well. For that reason, I am returning the entire record using a map and hit enter. And now products map reduce. I am using reduce function, and here lambda, let's say rec. So we got the entire record, and now I am applying the split function on this. So I have to implement if condition here, but I have to fetch the fifth field, which is price, and here we have to give rec1 and rec2. So rec1 is this record and the current record, and rec2 is the next record. So based upon current record and the next record, I have to fetch the fifth element, which is the product price, and I have to compare those two to see which one is higher, and I have to return the record which have the highest priced product between the two. And I will be doing and then for the next iteration, the rec1 will be the one which is of the highest from the previous two records, and rec2 will be the third record. Like that, you have to it will move. So let me implement that logic. So the way you can implement the if condition in single line in Python is it will be like x if x greater than or equal to y, else y. So it's a little bit different from traditional programming languages or other programming languages. Here I want to return rec1. The condition is if rec1 dot split on comma, which is our item, fourth item, and we have to typecast to float, otherwise it will compare as strings. So you have to be very careful with this. You can make mistakes. If it is greater than or equal to float of rec2 dot split comma 4, okay, and if the rec1 price is greater than rec2 price, then it will return rec1, else rec2, and I am closing the main bracket for the reduce function and hit enter. Yeah, the issue is I did not close the bracket for rec2 here and hit enter. So it is saying empty string to apply for float. Let me see whether I am using the correct one. 0, 1, 2, 3 and 4. Yeah, it is correct. So here is the script. It's the same thing. I am invoking the reduce function, and I am returning rec1 if the rec1's fifth field is greater than rec2, greater than or equal to of rec2's fifth field, which is product price. Otherwise I am returning rec2. The reason it was failing earlier was due to one record which has additional comma in one of the field. As we have imported using the scoop default import, all the data into all the tables is imported with comma as delimiter. And when I actually troubleshooted this issue, by logging into the MySQL database, use retail_db, select star from products, where product name like percentage comma percentage. There is one field, one record in which the product name itself is having comma. So when you have that, um, the delimiters got messed up, and it is passing the empty string to one of the data, and this condition of applying the function of applying the float to cast the incoming data's fifth field to get the product price was failing. So what I have done is I have deleted that record and reloaded into the HDFS and ran this command, and it worked. The way I have deleted the data is I got the data by applying the get command. The reason why I am emphasizing on this is they might ask, or they might give you these kind of scenarios as well. We never know. So I have ran this Hadoop fs-get command, and then after running this command, I have actually opened this file and by using VI editor, and then I have searched for that row and deleted that, and then I ran the fs-put using -f to override the existing file. Which will remove that one record, and then I ran this command. So I will actually document these things as part of the script so that you follow. And now you can see that we got the details of our product, which have the highest price, which is Sol E35 elliptical, which is $2,000. You can actually run the eval command again, or let me do this. Yeah, run the eval command. To get all the products ordered by product price, and hit enter. You can see the last product is Sol E35 elliptical, which is $2,000. So using the reduce function, we not only can compute the total statistics such as sum or count, we can also get the min or max as well by using script like this. So that being said, as of now I have covered the total statistics. I have covered count function as well as reduce function with if condition, also single line if condition, and we got the maximum valued product from our products table. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to ask any question, please use Stack Overflow and tag it with the Pyspark and Apache Spark. And if you want to discuss about certifications, please do join my LinkedIn group ITversity Hadoop certifications. Or if you want to get, if you want to discuss on Apache Spark itself, please join my group called ITversity Apache Spark. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.